these were two of the types of problems that were probably struggled with the most on the test, which I will give back to you in just a little bit. First one here, solve for D. Well, here's D. I have to get everything else out of there, which means I have to get rid of the V and the T. How are those attached to D? They're multiplied. So to get rid of them, I'm going to have to divide. So I'm just going to do this. I'm going to divide by V and T. Those are gone. Over here, I divide by V and T. So M over VT is D. All done. What's that? A few people did. That. Okay. Over here, this is different. I give you numbers for some of them. So when I'm giving numbers for some of the variables, I first replace those variables with the numbers. Well, F is 18 equals Q. That's what we're looking for. So Q is still there. Times R is 3. So this is 3 squared. Over N, which is 2. So I'm going to first square the 3. So 18 equals Q times 9 over 2. And now I'm going to solve. I'm going to multiply by 2. 36 equals A times 9. And then divide by 9. So 4 equals A. What do you think? Good stuff? Okay, I'm going to give you your tests back quick so you got those. So today our new stuff we're going to look at, we're going to take a few days to get into geometry and ratios. We're going to start today actually talking about ratios. A ratio is just a comparison between two numbers. For example, if I go around the room right now, we can compare dairy students to auto students. There are 2 dairy students to 6 automotive students right now. So I can either write it as a fraction like this, 2 to 6. I write it with a colon, 2 to 6, or even with the word 2, 2 to 6. No matter what form this is in, there are things I can do with it. Now I prefer the fraction form because there are things, what I can do with it is very similar to what I do with fractions. Both the 2 and the 6 can be divided by 2. So I can reduce this to a 1 to 3. I could do either of these reduced to a 1 to 3. Let's see, I can compare maybe these tables here. I can compare a width to length. Let's do a length to width ratio. Those tables are 6 feet long, so 72 inches. And wide is 18. Now, first of all, the inches cancel out. I can just divide that out. 72 and 18 both divide by 18. Gives me a 4 to 1 ratio. Now, here's one of the first differences between a ratio and a fraction. If this really were a fraction of 72 over 18, I would not reduce that as 4 over 1. I'd just reduce it to 4. With a ratio, we have to leave it as a fraction because it's always a comparison of 2 numbers, never just a single one. I might compare number of students in this class that are currently passing to, I'm not going to say failing, but we're going to say not passing. For some of you have to have a C or better. So in other words, yes, we'll see you in the spring. As a class as a whole right now, there are roughly 14 students that are safe and 4 that are not so safe. So again, the label, the students can divide out. And I can reduce this, both divided by 2, to give me a 7 to 2. Now, that's an improper fraction. If it were a fraction, I'd reduce it to 3.5. But, again, there's this another difference between a ratio and a fraction is a ratio never gets converted to a mixed number. It always stays as improper because it's a comparison between 2 numbers. So you have to keep that in the back of your head. There are differences between ratios and fractions. Now you will notice all of the ratios that I have done so far. This compared students to students. This compared inches to inches. This one was students to students. Both numbers had the same label. And that's a vital part of fractions. I have to compare two things of the same name or same label. Because of that, in a ratio, as we saw here, the label or the name cancels out. And the final ratio has no units or no label, 7 to 2 or 4 to 1. It's strictly numerical. Like on this one here, 4 to 1, length to width ratio. It doesn't matter whether we're talking about inches, centimeters, feet, meters, whatever. For every 4 units of length, there's 1 unit of width. It is completely unitless. You can use whatever unit you want to. It's just going to be 4 of the length units to 1 of the width units. So if I have something like 2 feet compared to 18 inches, is that a ratio? Say no. Why not? Different units. But I can convert that to be 24 inches over 18 inches. Now they're the same units. Inches cancel out. Both can be reduced by 6 to give me 4 to 3. Again, I don't convert that into a mixed number. I leave it as an improper fraction. So now what happens if I have two numbers that I'm comparing that don't have the same units? Let's say we send Jesse on a road trip, since he was talking about that earlier. And on this road trip, Jesse is going to drive 365 miles in 7 hours. Obviously here I cannot change miles into hours or hours into miles. This is not a ratio. This is what we refer to as a rate. And that is the first big difference between a ratio and a rate. Is a rate compares two things that have different labels. Where a ratio, they always have the same label. The second big difference is in a ratio, we quite often will leave it like 4 to 3 or 1 to 2 or 1 to 3 or 7 to 2. A rate is almost always reduced to what we call a unit rate. A unit rate means we have a denominator of 1. So to do that, we just divide by the numerical value of the denominator. This is 7 hours, so I'm going to divide by 7. That makes it 1 hour. Now this is still set up like a fraction, so the same rules apply. If I divide the bottom by 7, I have to divide the top by 7 as well, right? So 365 divided by 7 is 52.1428571 approximately miles. It's okay, it's not contagious. I can just do that in my head. I told you guys before, math is about patterns. Once you see the patterns, the calculation is really simple. You got to also remember I've been doing this stuff pretty much every day of my life for 20 years or so now. So anyway, once we have it as a unit rate, we often don't leave it in this like ratio or fraction form anymore. Let's say I'm going to round that to 52.14. I would most likely do it like that, where now the fraction is kind of hidden in the units. The appearance of the fraction is gone in the numbers, and it's kind of hidden within the units. Might even hide it even further like this, 52.14 mph. But we do have to keep in mind that that is a rate. It is still a comparison between two numbers. It's a fraction. So let's say you go on a trip and you find out your car gets 26 mpg. What's mpg stand for? Miles per gallon. Whenever you see something like that, 26 mpg, you need to think this, 26 miles per 1 gallon. Because this is the form we need it in to do calculations with it. If it's not in that form, we can't do a whole lot with it. Well, let's take a look at some other common rates. Other common rates we run into for you guys, I mean, obviously miles per hour, miles per gallon, wages. You get a job. You're going to get $12.30 per hour. That's a rate. If you work, let's say you work 35 hours and you get paid, let's see, what do I get paid? Let's go $560. Your rate is $560 for 35 hours. If you divide that out, that's $16 per 1 hour, or $16 per hour. Make sense? Okay. Ratios. There are a ton of applications for ratios. Now, rates, again, there's all sorts of other rates out there. Interest rates, 6% per year. Yeah, that'd be a loan, not an investment right now. If you're getting 1/4% per year on a savings account right now, you're doing well. You see them all around. Ratios. There's all sorts of ratios out there, mechanical and otherwise. One. Now, this is the part of the class where we get to expand your imagination because I'm going to draw pictures. And my artwork leaves a little bit to be desired. Wait for it. Anybody got it? Somebody said it over there. Gears. For a gear ratio. Now, gear ratio is the number of teeth in the driven gear to the number of teeth in the driving gear. So anyway, this one has, if I count them, there's 12 teeth here. This one has 8. How do I know which one is driven and which one's driving? Well, at this point, I need more information. So back to the artwork. That's a shaft, pretend. Pretend that's a little electric motor. If I were to separate these two gears, which one would stop turning? The 8. That is the driven gear. It is being forced to turn. It's being driven by the other gear. The 12 is the driving gear because it's connected to the power. It's the one that's forcing the other one to turn. So this would be 8 to 12, of course, reduces to a 2 to 3 gear ratio. Now that ratio describes the number of teeth, but it also describes other things, the ratio of RPMs and stuff like that. Ratio of torque, all sorts of wonderful things. We don't have anybody from over here there, but this one might be more familiar. When we're talking about pulleys, there are no teeth. So we measure the size differently. Counting the teeth on the gears is just a way of measuring the size. If two gears mesh together, the distance between teeth is the same on the gear. So counting the teeth is just measuring the distance around the gear. Well, or around the circle of the gear. On a pulley, of course, the distance around is just pi times your diameter. So all we really have to compare is the diameters. So let's say this one is 10 inches and this one here is 4 inches. It's still driven over driving. So I need to know a little more information. Pretend that's a little electric motor. Which one goes on top now? If I cut the belt, which one stops? The 10. That's the driven gear. 4 is the driving gear, or driving pulley in this case. So that reduces to a 5 to 2 pulley ratio. A little bit outside of the field of mechanics. In construction, you talk about slopes and pitches. We're dealing with a roof, which you have a height, you have a span. Let's say that this is 6 feet high and a 24-foot span. Your pitch is height over span. 6 over 24, or a 1/4 pitch. That's your ratio. Pitch is just a ratio. Now, most of us are not used to seeing roofs described like that. We're used to seeing roofs described as slope. Slope is a rise over a run. Now, the rise here is still the 6 feet. The run, however, is not 24. It is 12 feet. Half the span. So 6 over 12, we could reduce that to 1/2, but usually when we're dealing with slope, we leave it as on a 12. So it's a 6/12 slope. The 6/12 roof is probably what most of you are familiar with here. Other applications. Let's go back to automotive, to mechanical. Again, we're going to stretch the artwork some. Think she's running a little loose? Yeah, a little bit. Obviously, these are cylinders. We're going to talk about a compression ratio. Don't know how good a compression this one is going to have, but compression ratio in an ideal cylinder with no major leaks is the expanded volume over the compressed volume. So let's say that this is 48 cubic centimeters compressed and 528 cubic centimeters expanded. Which one goes on top? 528. 48 on bottom. Now, with any ratio, the units divide out because they're the same. That's an 11:1. 11:1 compression ratio. Both of those can be divided by 48. What's that? It's a little high for, what, 7 or 8 is usually 8, 9, yeah. But 16 is usually diesel, isn't it? 15 to 18, somewhere there. This is a small engine. Anyway, other ones for you guys. A differential ratio. Differential ratio is usually your ring gear to your pinion gear. Differential ratio. You got your drive shaft coming back in. Usually have a ring gear like that. And obviously, this is a very simplified differential. The axle going through, and the gear on the axle going like that. And let's say we have, what, 48 teeth here, 16 teeth here. Your ratio here is 48:16. Or 3:1 differential ratio. A little bit trickier, the transmission ratio. Transmission, and this is again a very, very simplified transmission. But a transmission is just, especially if you're looking at an old mechanical transmission, automatic transmission is a whole different story. If you're looking at an old manual transmission, there are some that are actually this simple. So you've got your drive shaft coming in. It has a gear on it that meshes with another gear on a sleeper shaft. This is not drive. This is coming from your crank from the engine. This is the drive shaft going out to Let's claim it's a rear-wheel drive. It's a little simpler to think of it that way. And let's say that this one here has 16 teeth. This here has 20 teeth. This one here has 24 teeth. And this one up here has 30 teeth. Our transmission ratio is a combination of two gear ratios. So for these two gears here, which one goes on top, 20 or 16? 20, because if I separate them, the 20 will stop turning. The 16 is connected to the crank. That's connected to power. 20 over 16. Now I'm going to reduce that. Both of those can be divided by 4 to give me a 5-to-4 ratio. What's my gear ratio here? Which one goes on top, 30 or 24? The 30, because if I separate them, the 30 is going to stop. The 24 is closest to the power source. Both of those can be divided by 6 to give me, once again, a 5-to-4 ratio. The transmission ratio is found by, again, it would work nicer if they weren't the same ratio, but it's found by multiplying the two ratios together. 5-to-4 times 5-to-4, that's a 25-to-16 transmission ratio. There's also something in automotive called final drive ratio or total drive ratio, which is, like you might hear a 411. 411, that is the 4.11 to 1 is what that is. That's 4.11 turns of the crankshaft to 1 turn of the rear axle. I guess on a front wheel drive, probably just from 1 turn of the axle, I suppose you could probably define it as. We'll let Rick get into that more. Now, on the dairy side of things, it's usually the rates that are a little bit more applicable. On the dairy side, you might be looking at feed. I guess it could be considered a ratio. You might look at a grain to production ratio. And you might have them on a 1 to 4.8 or something like that, which means 1 pound of grain per day for every 4.8 pounds of daily production. I'm blacking out on others right now, and it's time to give you your homework anyway, so let's give you the homework. Sorry. Page 282. Exercise 7.1. 1 through 65, the odds. Oh, one of the other good ones out there that's kind of applicable in everyday life. If you ever go to get a loan, something they're going to look at is a debt to income ratio. Now, debt is regular monthly payments. So let's look at your income. What do you guys predict your income will be when you're done with here? $3,000 a month? $36,000 a year? Let's just put that down. Monthly income. That's before taxes, obviously. That's gross. It really isn't that hard to get $3,000 a month is about $18 an hour, or $15 an hour with a little bit of overtime every week. So that's not impossible to do, not tough to do. But let's look at debts. Let's say you want to buy that fancy truck. So you got a $500 truck loan, right? Let's say you got about $200 for credit cards. You want to buy a house. So you look at a house, let's say you're looking at, roughly a $150,000 home. The loan on that is going to be roughly $850 to $900 a month. So what they would do is they would look at that proposed payment amount for that house you're looking to buy. They're going to add it to these other debts. Now, they're not looking at your electricity cost or anything like that, or gas or anything like that. Those are expenses. Those are not debts. Those are not predictable regular monthly expenses. So we've got $500, $200, and $850. That adds up to $1,550. So that gives you a debt to income of $1,550 to $3,000. And divide those by 10 to get 155 over 300. Divide by 5 to get 31 over 60. Most of your banks, by the way, will not allow you to go over about a 1 in 3 debt-to-income ratio. So $3,000 a month, you'd be looking at a maximum $1,000 a month of debt payments. So you either have to get rid of the credit cards or get a cheaper car or look for a cheaper house, one of the two. Back in the 10 years ago or so, a little bit, 10, 12 years ago, they started taking that recommended 1 to 3 debt to income ratio, and they started stretching it to 2 to 5. This is basically 33% of your income is debt. This is 40% of your income is debt. This ratio is part of what caused all the problems with the mortgage collapse and stuff like that. They were giving out loans to people that the numbers predicted they couldn't afford them. So that is a big thing now. That's almost more important right now than your credit score. Most people's credit score is struggling a bit right now because of what's happened in the last 10 years. When you go to get a loan, that debt to income ratio is huge. So don't have any silly debt sitting out there if you can avoid it. Okay, I'll shut up now and give you guys time to work.